From the Southeast Asian capital city of the Philippines, Manila, I bid you good morning, good afternoon, good evening, whatever the time may be, wherever you are in all of the world's time zones. Prolific they are indeed. I think there's 24 and a half of them or something like that. A whole bunch. We're certainly in a very different one. The sun is up. It's the middle of the day, about 1 o'clock, a little after 1 o'clock in the afternoon here. But my studio is darkened down appropriately for the program we're going to do. In fact, it's going to be a particularly good program tonight. Coming up very shortly is Dr. Robert Lanza. Now, Dr. Lanza is one of the most respected scientists in the world. In fact, a U.S. News and World Report cover story called him a genius, a renegade thinker, even likened him to Einstein. That's pretty heavy stuff. Lanza is currently Chief Scientific Officer at the Advanced Cell Technology, at Advanced Cell Technology, and an adjunct professor at Wake Forest University School of Medicine. Has hundreds of publications and inventions, 20 scientific books, including Principles of Time Engineering. That's right, time engineering, recognized as the definitive reference in the field. My kind of guy. But if you look at Wikipedia, you find all kinds of interesting things that this man has accomplished. For example, he was part of the team that cloned the world's first early human stage embryos for the purpose of generating embryonic stem cells. 2001, first to clone an endangered species. First to demonstrate that nuclear transplantation could be used to reverse the aging process. I'm particularly interested in that one. Showed it's feasible to generate functional oxygen-carrying red blood cells from human embryonic stem cells under conditions suitable for clinical scale-up, and on and on and on and on. Hence the reference to Einstein. So we don't have a lot of time with him tonight, I understand. He said he could only spend a couple of hours. So what we'll do is open lines and news after that. Just a couple of quick items before the break. All the ABs are well indeed, including the three furballs, Abby, Yeti, and Dolly. Everybody asks about them. They're here and well. Asia, there's a new picture of Asia. I cloned myself 3 years ago, and you can see a picture of her on the website, coasttocoastam.com. Asia is now talking up a storm, and there's a new photograph, 2 or 3 days old only. Those are her blocks. When she gets a tower built, she brings me into the other room, and she goes, ta-da! So she was in that mood when that picture was taken. My antenna is finally up, cutting through hundreds of yards of red tape. It's up, and I've made some friends, some American expats, a couple of friends over in Thailand. I want to say hello to HS0ZCW, Charlie, and HS0ZCX, Chuck. Charlie's in Bangkok. Chuck is way up in northeast Thailand, adjacent to the Laos border. And let me tell you, this antenna's working. Talk to K3ZO Fred in Washington, D.C., K3TW Tom back also in the Washington, D.C. area, so hello to you guys. So you can tell it's working. And by the way, we rolled through a 6.1 earthquake the other day. If the weather over here doesn't begin to change somewhat favorably, I'm going to be saying from the high desert. We're in El Nino conditions. We haven't had rain in, save a couple of sprinkles. We have not had rain in, I don't know how many months, 5 months perhaps? And that's just unheard of for over here. I mean, we have rainforests. You need rain to support rainforests. And we really are in the middle of a drought, a very serious drought, beginning to affect hydroelectric production and that kind of thing. So we're praying for rain over here after having, in the last rainy season, nothing but this year, nothing at all. Anyway, coming up in just a moment, Dr. Robert Lanza. Well, all right, let's get right to it because he says he can only spend a couple of hours. We'll try and stretch that a little bit, but you never know. He's probably got something he's got to do. Dr. Lanza, welcome to Coast AM.
Thank you. It's a pleasure being here.
I see on the Wikipedia site there's a picture of Barbara Walters interviewing you.
Yes. Yes. She came to my house a year or two ago and did a piece for her special on aging.
I see. All right. Well, I see what you want to talk about. It's your book, of course, but you've done so much that, given the time, I'd really like to ask you about a few other things. Sure. Let's start there, though. What is biocentrism?
Well, it's actually an out-and-out challenge to our view of the world. We think that life is just an accident of physics, but a long list of experiments actually suggests the opposite. So amazingly, if you add life to the equation, you can explain some of the biggest puzzles of science. So, for instance, it becomes clear why space and time and even matter itself depend on the observer. And it also explains why our universe appears to be fine-tuned for the existence of life. And according to this theory that I'm laying out, consciousness is actually the key to understanding the world.
All right, slow up a little bit. I'm fascinated by consciousness. It's been my favorite topic for a long time. The world does appear to be fine-tuned for human occupation.
Right.
And there are two great and grand theories about that. One is design, of course, intelligent design, and the other is that it's just that way. It has to be that way because otherwise we simply wouldn't be here. So where do you fall in that?
Well, I mean, obviously the universe has this long list of traits that makes it appear as though everything was tailor-made for us. So, for instance, if the Big Bang had been one part in a million more powerful, the cosmos would have blown out far too fast for stars and worlds to form. Or if the gravitational force was a hair less, stars wouldn't ignite, and there simply wouldn't be a sun. And the result, of course, is no us. And it turns out there's actually over 200 different parameters so exact that it strains reason to think that they're just random. You tweak any of them, and we never existed. So none of these are predicted by any scientific theory, and they all seem to be very carefully chosen to allow for life. And so, obviously, according to biocentrism, with life and consciousness as the key, it's obviously obvious that the universe is simply the logic that would be necessary for the observer.
Okay, but I'm still not sure I'm clear on this, on which side you're falling on. In other words, yes, all of that certainly is true, but are you suggesting that there was or was not intelligent design?
Well, intelligent design actually, in the general sense of the word, is referring to that there's a creator,
That's right.
That there was
yes, that's right.
somebody in a ball up in the sky that said this is the way or that. And and biocentrism doesn't really discuss whether or not that's right or wrong. What it's basically saying is that based on various experiments that have been carried out repeatedly in physics, for instance, we know that virtually everything that you see out there, every particle, depends on the observer for their very properties. And it turns out that life and consciousness are absolutely essential to reality. So that it's clear that without an observer, without the animal observer, you could not actually have existence. You could not have reality. So therefore, you could not have a universe where life does not exist. That life is simply a reflection of, when you think of space and time, they're actually tools of our mind. They're not these external objects. So that the universe that we think of is basically a concept that basically is the complete spatial temporal logic of the animal observer, if that makes any sense.
Put simply, it's all in our minds.
Well, yes, actually, it turns...
So, without us to observe it, are you suggesting it would not be? Well, for us, it wouldn't be, obviously, but I mean, it would still physically, the physics of everything that's here, plus or minus humanity, would still be the physics of here.
Well, it actually turns out, and there are very real experiments that show you this, is that there is not a single, that matter, the properties of matter do not actually exist until they're actually observed. They actually exist in what's called a state of superposition, so that they're just probability waves. And so let's just give you an example. So this is an experiment called the two-hole experiment. When scientists watch a particle pass through two holes in the barrier, the particle behaves like a little bullet, and logically it goes through one hole or the other. But the strange part is that if you don't watch it, it acts like a wave. It can actually go through more than one hole at the same time. So you say, well, how can that be? If there's really a particle out there, how come it would change its behavior on whether or not you watch it or not? And the answer is simple, that reality is a process that does involve our consciousness. Or even one of the mainstream foundations of quantum theory is something known as Heisenberg's uncertainty principle, which you may have heard of. If there was really a world out there with particles just bouncing around that existed independent of us, then why should we not be able to measure all their properties? And it turns out that if you decide to know the exact location, you can't know the particle's momentum. Or if you look at the momentum, you can't know its location. So why should the properties of matter depend on what you decide to measure? Again, the answer is simple. The particles just aren't out there independent of our consciousness. And it goes on and on. There's something called entangled particles.
Yes.
Yeah, and if you were to send these pairs of particles in opposite directions to opposite sides of the galaxy, they would actually behave as if there was no space or no time between them. And again, why? And that, again, is because space and time are not these external objects. They're really tools of our mind.
Well, nobody's been able to adequately explain to me how that works, how those particles know to behave in a similar fashion across time and space as though it did not exist, and they do. It's not possible, and it's not possible to explain. At least I know nobody who has yet done it. You're suggesting biocentrism does explain it.
Yes, I think one of the mistakes, one of the faulty assumptions of current science is that space and time are these external objects. And as far back as Immanuel Kant, he knew that space and time were really forms of our intuition, of our understanding. So wave your hand through the air. You can take everything away, but what's left? And the answer, of course, is nothing. And the same thing applies for time. You can't put it in a bottle like milk. So you can look at anything, say the radio. You can't see that through the bone that surrounds your brain. It turns out that everything you see and experience right now is a whirl of information occurring inside your head. So space and time are simply the mind's tools for putting it all together. And we carry them around like turtles with shells. I mean, if anyone falls off to sleep or dozes off here, you'll probably go into a dream. And yet, in your dream, your mind certainly has the capacity for you to fly or jump off cliffs. You can create a spatial temporal reality. So clearly, your mind has the ability to organize things according to specific spatial temporal rules. I don't know if that's...
Are you suggesting that if we were to be able to learn to use our consciousness in a specific way, we might be able to alter what we perceive as reality?
Well, unfortunately, if you jump off the roof, you're going to get hurt very badly, regardless of whether you want to fly or not. So you do actually follow the rules of causality. So you can decide whether or not you want to, have Captain Crunch or cornflakes for breakfast. But what biocentrism is saying is that reality is a process. It's not just something that you just open your eyes and it's out there. Our view of the world is the same as like a chickmunk or a squirrel. The squirrel opens his eyes and the acorn is just miraculously there, and he grabs it and scurries up the tree without any further thought. And we humans are really the same. We wake up in the morning and the world is just magically there. But again, as I just mentioned, there are experiments that show that not a single particle exists with any real properties until it's observed. In fact, one of Einstein's colleagues, John Wheeler, he actually was the guy who coined the word black hole. He actually said that no phenomena is a real phenomena until it's observed. And even Stephen Hawking at this point now has a new concept of the universe, what he calls his top-down theory, where he's saying that the actual observer actually determines the past. If you think about it, if the particles right now in the present are not determined until you observe them, then how can there actually be a past? So this stuff starts to get very, very weird, which is why you can understand the physicists are having such a hard time with it.
I think it was Einstein himself who mentioned when talking about quantum action that it was weird. I think that's the word he used, weird or something like that.
Well, exactly. Imagine, the scientists are doing an experiment. They send a particle through these two slits in the barrier, and like I said, at first, when they're observing them, they go right through like little bullets, just like you'd expect. But why would they be able to go through more than one hole or two holes at the same time when you're not looking at it? The only difference, and this has been done over and over and over, and it completely depends on whether you even think about observing it. So the key here is the observer, not the apparatus, as some people had initially thought.
That would imply that we sort of create our own matrix. To use a movie term.
Yeah, actually, it's true to a certain extent. I mean, right now, time is just saying that there's this space and time out there is sort of like you mixing eggs in with the flour to make a cake. And again, that's silly. If you think about it, space and time are not like the shells you pick up along the seashore. It's not this external matrix. It's basically the matrix that your mind is actually doing right at this current time. I mean, if you think about it, right now, you're talking to me on the cutting edge of all of infinity, on the cutting edge of time. If you were to take all the hours, all of the days that have existed since the beginning of time and pile them on top of one another and then sit yourself on the top, that's how we are thinking of time. And that's silly. The mathematical probability of you or I just being one in a gazillion chance of being on top of time is really zero. So we really need to start thinking more of how the world is put together. Again, that reality is a process, not this object out there.
All right. There is a good hard science to support this?
Well, as I mentioned, there are literally, hundreds and hundreds of different experiments that now are actually the cornerstone of all of quantum physics. So again, I mentioned to you this two-hole experiment. Again, the Heisenberg's famous uncertainty principle, the entangled particles, and there's actually a really very interesting experiment, actually, that was just published a couple years ago in one of the prestigious scientific journals called Science. And what they actually showed that was flipping a switch when a particle went into an apparatus could actually retroactively change an event that had already happened in the past. And, of course, we live in that same world. So, again, there's very real, hard experiments that are telling us that particles simply do not exist out there with real particles until they're observed.
Right. Okay. Well, let's look at the quantum action of this bizarre quantum action of particles that doesn't make any sense in the sense that we know there has to be communication between these two particles. There has to be. How can they know to flip and flop exactly the same way, no matter how far apart they are, exceeding the speed of light?
Yeah.
I mean, this completely defies everything we thought we knew about physics, completely defies it. And so there's got to be some kind of communication that's taking place in a realm that we haven't yet uncovered.
Well, this is exactly it. Again, Einstein said that, the universe was all put together according to, the speed of light, and that there, was this space-time matrix. And exactly, if that were the case, obviously nothing could happen faster than the speed of light. And, of course, these experiments very clearly suggest that is not the case. And as you mentioned, they actually did an experiment a few years ago where they actually sent two particles on fiber optics 7 miles apart. In one particle, when they changed one particle, it instantaneously changed the other particle. So these are real experiments.
That's
and
right.
if that's the case, why did they act as if there was no space between them? How could they possibly do that? And how come it worked instantaneously as if there was no time delay? And the reason is that space and time are not these external objects. They're just the way they're forms of our intuition. They're the way our mind actually puts things together. So they're not real hard objects, and that's where science goes astray. And we all know in our mind that, or I should say, in logically in our heart is that, you know, looking out over the ocean or whatever, that's space. What is it? You know, again, it's not a thing. And the same with time. What is time? These are very intangible things. They're not like, you know, a rock that you'd pick up off the ground. So we know there's something funny about space and time. And the reason there's something funny is they're not these objects. They're not these things.
Got to think of how to ask this. We're coming up on a break, but there have been a lot of consciousness experiments. I ran a few of my own a few years ago that literally scared the hell out of me. I mean, we had millions of people concentrating on producing rain, and by God, we produced rain in some spots that really, really needed it. We'll talk about this after the break. Doctor, hold on. It goes very, very quickly. Consciousness, time and space, all my favorite subjects from Manila, Philippines. I'm Art Bell. Actually, what Einstein called it was spooky action at a distance. Weird would work. It's kind of unlike Einstein to dismiss anything by just, you know, saying spooky action at a distance, but certainly that's what it is to us right now. While there are scientific experiments telling us this does go on, clearly, it doesn't tell us how just yet. Dr. Robert Lanza is our guest, and we're talking about biocentrism. We'll be right back. I'm Art Bell for George Norrie, taking a deserved night off. I may well be here next week, same time, same station, and all that baloney. All right, Doctor. Let me back up a little bit. There are universities doing experiments with consciousness. Are you Are you familiar at all with those experiments?
Yes, I'm aware of some of that work. Yes, absolutely.
Okay, the eggs that are planted all over the world, they call them eggs, are really computers, and they're monitoring and have been for years now big events, 9/11 type things, and then taking a look at any variations in what these computers are saying. They're spitting out random numbers, and when they begin to be not so random, that registers on a scale. And, for example, when 9/11 occurred, it went off the scale. So they believe they're looking at a mass consciousness reaction, that sort of thing.
Mm-hmm. Yeah, I'm not too familiar with the details of that. I've heard about it again, and I have to concur, of course, that consciousness is indeed everything. On the other hand, trained as a scientist, I'm a bit conservative and skeptic, but I have to agree. There's a lot more going on than science currently acknowledges, and I think obviously biocentrism opens up many possibilities that might even explain some of those results.
Uh-huh. When you write a book about this, which really is a theory at this point, because even though there are experiments that sort of underline the whole thing, they don't absolutely prove it yet because it's still spooky.
Mm-hmm.
We don't know what it is. So it creates a lot of controversy. I imagine your book has done that.
Absolutely, yeah. You have to remember, again, that this is an out-and-out challenge to physicists and indeed our whole view of the world. So it's really not surprising that some people get a bit defensive, even a bit nasty. But that being said, I've actually gotten dozens of emails from people, from professors, even chairmen of scientific departments at Johns Hopkins and Columbia. And the main problem, I think, that is here is that biocentrism is a proposal for a paradigm shift. So by definition, a new paradigm always appears to be nonsense from within the established paradigm. Again, that's what science is all about, to carry out experiments and to determine what's really going on. But you have to remember that scientists are human beings. They're people, too, and they have prejudices and preconceptions like the rest of us. So it's hard to as Einstein once said, God doesn't play dice. And what he was basically reacting to was the fact that he couldn't wrap his mind around all of this new physics, all this new quantum theory that said that probability rules and that there were these probability states. So it takes time for people to really go through and change their whole way of viewing the world.
Is it possible that, let me ask again, that if we directed consciousness in a certain way or changed our perceptions, that it would change our reality?
Well, again, we know for scientific facts that decisions you make absolutely do impact what's going on in the physical world. I mean, we know experiment after experiment that, again, as in the two-hole experiment, if you do one thing, the properties of matter will be one way, and if you do another, it'll be different. And again, as in that science experiment that was carried out a couple of years ago, and there's a long list of such landmark experiments, we know that, again, you send these particles through this apparatus, they make a decision as they go through a fork, and then later on, well after that event, you can make a decision whether to flip the switch on or off, and it will actually change what that particle actually did at that previous fork. So this is not, science fiction. This is not speculation. These are real experiments.
So biocentrism does not rule out intelligent design, perhaps wisely in the book. It doesn't
actually, intelligent design, if you look at it in a generic sense, yes, of course there's intelligent design in that, yes, the universe is designed. What science says right now is that, 14 billion years ago, the universe just popped out of nothing one day with all the laws of nature intact, out of nothing. Well, that's absurd. So the point is obviously there are very specific laws of nature. There are gravitational constants. There's all sorts of properties. And where do they come from? They didn't just randomly just come out of nowhere, and the universe isn't randomly expanding and into nothing. There is a design, and the design, as many great philosophers in the past have said, is because the laws of nature are in our mind. It's actually the way we actually construct reality.
The laws of nature are in our mind.
Right. So again, as I mentioned to you, space and time are not these objects out there. They're actually tools of the mind. They're actually the way the mind puts things together. So again, the way to look at this is right now, look at anything in the room, okay? And you say, oh, well, there's a chair, there's a table, there's the radio. But the truth of the matter is this, you can't see that. You can't see through the cranium, through a vault of bone. Everything you see out there is happening in your mind. It's being constructed. So your mind is actually putting that all together according to very specific rules. And these rules, in our particular case, are the laws of space and time. That basically the way the mind is actually able to do that, whether it's in a dream or schizophrenia or in reality. And in all those cases, the objects and things you see, you experiencing them according to those rules that are happening in your mind.
Einstein said the distinction between past, present, and future is only a stubbornly persistent illusion, which is essentially it's kind of what you're saying, a stubbornly persistent illusion, meaning the whole thing is an illusion. Can choices we make really change anything in the past?
Well, yeah. Time, again, as I said, it's just a funny thing, and again, as I mentioned, we're talking right now on top of the cutting edge of time, which again is really a silly idea. So instead of thinking of time, like this arrow, you should really think of it like one of those old vinyl records you used to play. Depending on where the needle is, you hear a certain song, and then that's the present. And before and after is the past and the future. So all the songs exist simultaneously, even if you can only experiencing them piece by piece. And again, this is sort of what that science experiment and other experiments like it have been basically trying to tell us. And again, no physicist questions the fact that particles possess a range of possible states, and that it's not actually until you observe them that they take on real physical properties. So until the present is determined, how can there actually be a past? And again, Stephen Hawking, as well as the great physicist John Wheeler, agree it can't really be any other way. So John Wheeler actually died last year, but just before he died, he had said he's well known for having said that when you observe light coming from a distant quasar, obviously billions of years off, we're setting up this huge quantum observation on an enormous large scale. And it means, he said, that measurements that we make right now on that light when we observe it determines the path it actually took billions of years ago. So, yes, choices we make now really do change the past.
What possible, if we were to refine this and understand it perfectly, what would we be able to do? Would we be able, for example, to time travel?
Well, yeah. Well, it's interesting. Exactly. There's obviously string theory and other theories that have tried to address this as well. But I think sometime in the future, science is going to be able to create realities that we can't even begin to imagine. So as we evolve, we'll be able to construct other information systems, other universes that are based on logic completely different than ours and that are not based on space and time. So right now, for instance, our destiny is to live and die in the everyday world of up and down. But what if, for example, we change the algorithms so that instead of time being linear, it was three-dimensional, like space? And if that were the case, consciousness could move through the multiverse and would be able to actually walk through time just like we walk through space. So after creeping along for 4 billion years, life would finally figure out how to escape from its corporeal cage.
Can you imagine how that might be done?
Well, yeah, absolutely. I think the whole key, we're trying to understand this now. I think the whole field of artificial intelligence is trying to, how to create thinking machines. And in order to do that, we really need to figure out those algorithms that allow us to actually have what we call consciousness. And that, again, is understanding those rules that I mentioned that we use in our mind to construct space and time. And once we know how that works and how the mind is constructing that the same way as it does it in our dreams, then we can modify that. And at that point, it won't be rockets that take us the next step. I mean, we're simply going to be able, to create realities that exist outside the known physical universe.
Do we get there when we discover the theory of everything?
Well, I think, yes. I think the theory of everything right now, the way physics or science conceives of it is they want to put together some mathematical equations that explain the various forces of nature, and that's all great. But what a real theory of everything should do is actually not to say, here's an equation. You can write an equation down. It doesn't mean anything unless it explains something very real. And once we truly do know how the world is constructed, how it all operates, yes, I think that at that point, there's going to be a lot, that we're going to be able to do. That'll be quite amazing.
I would love to be able to travel to the past. I would just simply love it. And it's been a dream all my life. And you think that one day that will be possible. Is it going to take some sort of discovery in physics, some sort of machine to assist in that? Or do you think that it can be done in consciousness, with consciousness?
Right, yeah. So first of all, I doubt we could ever do anything using a machine, because I think that I think you're thinking, you probably need to think more along the lines. Actually, Christopher Reeves was in a movie called Somewhere in Time.
I was just about to mention that movie.
And there is a reality to this. The truth of the matter is, as I said to you, when Einstein said that that the past and future are illusions, he's very real. Again, as I mentioned to you, we're not just accidentally, like I said, sitting on top of infinity. It's a silly linear idea, and so I think that once we get past that old way of thinking, that I think we'll start making these breakthroughs, and probably rather soon. So I think right now people, for instance, are trying to construct thinking machines, and they're putting together these various wires and senses, and this is all great. But those machines will never think. We're never going to have David of AI or Data from Star Trek. The way we'll do that is once we understand what consciousness is. And consciousness is exactly what space and time are all about. I mean, the external world is the spatial world, and things occur in our mind to make things move, the temporal component of that. And once we understand, as, again, Immanuel Kant, pointed out, hundreds of years ago, I think then we can put together the algorithms so that we will then create a machine or a computer that is able to process information according to those algorithms. And once we can do that, the constructs, these restrictions that we have right now that we're thinking of space and time, they don't really exist independent of the observer. So that they're not these external things. And once we figure out that, I think we're going to be able to manipulate those and indeed through those algorithms, modify them to do whatever we want. I mean, again, that's exactly what you're doing right now. You can go to sleep right now and dream about something else, and you'll experience it, and it'll be just as real as right now you're talking to me. I mean, those are things that can actually be constructed simply by, as I mentioned earlier, our mind puts things together. So, for instance, I could use a little genetic engineering and could make everything that you see that's red turn green, or make it vibrate, or make it make a noise. So, again, you can think of, for instance, a frog, a tropical frog. To us, it may feel, cold and dry. I mean, it may feel hot and humid, but to that frog, it would feel cold and dry. So this logic applies to virtually everything. So I think that we are going to be in a position at some time in the future to start playing around with those rules so that we can actually do some of those amazing things, like you said, basically deal with time differently than we do today.
Do you think it would be possible one day for a machine not only to be artificially intelligent, but to achieve consciousness?
I think the only way it can be achieved, of course, is using, those algorithms, because the reason for that is, as I mentioned, we know from every experiment that's been carried out in quantum physics that particles simply aren't out there. They exist in this state of probability. They're just not there. And it's only through the observer that they take on real particles. And again, the same for space and time. So until we figure out the nature of that relationship, nothing can happen. So right now we think that we can build from one side of nature, the physical end, without the living, and we can't. And that is why our theories just are not working. And so again, this is why in those two-hole experiments, if you're not observing it, it can go through all the holes at one time because it's not really there. It's not until your consciousness isn't involved that it actually, the scaffolding is laid out. So again, I think we will be able to create machines that can think as long as they employ the same rules and algorithms that we enjoy.
Think. But I said consciousness. Take your best shot at defining consciousness for me.
So reality, as I mentioned earlier, is a process, not a thing. So you look outside and you go, the rock and the table are there. And again, we know even from classical science that it's not. I mean, red is subjective. There's no such thing as red out there. That's in your head. So, and that applies to all sorts of things. So you look at, again, the kitchen and you say, well, it's, your stove or your refrigerator are there. But again, we know that not a single particle, according to physics, exists in that exact, it has no properties whatsoever until it's observed. So what consciousness is that process. So we think of it like a film. You have these different slides that one follows the other, and those are spatial states. And then what happens is in your mind, they basically, when you run that together, you actually get the sensation of movement, of action. But what is the glue between those slides? There isn't. That is actually just simply the way the mind perceives change in spatial states. And again, this is exactly why Heisenberg's uncertainty principle is in play. It turns out that if you think of this like a projector, that if you stop the projector, you can know very precisely. For instance, say you have a movie film of someone playing an archery tournament. If you stop that film right in still, you can say, there's where the arrow is. It's 20 feet above the grandstand. But you know nothing at that point about what it's doing, its momentum, where it's going. So when you start the projector again, you go, there it is. It's going to fall over there. It's going so fast or whatever. But then once it's moving, you have no idea of its exact location. And that's exactly what we're seeing in the very structure of the physical world. I mean, we've done these experiments, and we know that there's all sorts of these complementary properties that if you measure one, you can't know the other. So this is a real feature of the world.
If none of us were left to observe, what would be here? Hold your answer, because, once again, we're at a break. It goes very, very quickly when you're talking about this sort of thing. My guest is Dr. Robert Lanza, who's been compared to Einstein. Biocentrism is his book, and I'll just bet you it's generated all kinds of controversy. We'll be right back. From the other side of the world, Manila, Philippines. Just about, as a matter of fact, from Washington, D.C., the gentleman I talked to back there, if you drive a pin from Washington, D.C. straight through the globe, you're pretty close to the Philippines. It's just about exactly the other side of the world. That's amazing in itself that I'm able to sit here on the other side of the world and talk with you and Dr. Lanza, who has written a book that I'm going to have to ask about because I'm not sure it makes sense. Here we have a hard scientist, a man who literally pioneered stem cell research, such hard science, turning to this theory. I wonder, we'll ask in a moment. Dr. Robert Lanza will be right back. Curiosity killed the cat, I guess, right? Schroeder's cat. Doctor, how does a hard scientist like yourself, a man in the hard sciences, I mean really deeply in the hard sciences, turn and begin thinking about biocentrism and that sort of thing?
Well, I mean, that's exactly what a scientist is supposed to do. He's supposed to follow the experiments and make decisions and try to figure out what the world is all about based on the experiments. And basically what has been going on is that we've been having all these experiments, the science experiment, the two-hole experiment, all these, just sweeping them under the rug. And there's all sorts of very flimsy excuses. So, for instance, everyone says all this weirdness that we've been talking about only happens in the micro world. There are really two worlds, the little world of the atom and then the big world where you and I live. But the thing here is that doesn't hold up, because there have been new experiments recently that are showing, for instance, there's something called buckyballs, that are these huge carbon-60 molecules. And they show that those molecules actually now are following the same rules and properties and the same weirdness that we actually are seeing in the micro world, all the quantum phenomenon. And likewise, even more recent experiments where they use crystals are actually showing that this weirdness is now going into waves up to a half an inch. And there are new experiments actually on the books that are going to show, it's called scaled-up quantum superposition, that will actually show, hopefully, that this occurs at the level of tables and chairs of you and I. So we can't just keep ignoring and saying, okay, we'll worry about it and downstream. The experiments are real, and we've got to accept the conclusions. The problem is that goes against everything we've been taught and trained ever since, kindergarten. And so what I'm trying to do as a scientist is to put these experiments together in a way where they don't contradict one another. And the conclusion is actually what the physicists originally concluded, something known as the Copenhagen interpretation, where, again, if you extrapolate the results to the world, you arrive at more or less the same conclusion. They just didn't have an appropriate explanation. And as a biologist, I'm stepping into the equation, and I am saying, yes, that's because you can't explain the world without taking into consideration consciousness, what's going on in terms of our perception of the world, in terms of what's going on in the mind.
Okay, well, if it's going on across the board, even in the larger world that we observe every day, and we finally understand it, how will it impact our world?
Well, again, as I mentioned earlier, I think that you're going to see, once we understand what's going on here, obviously not only in terms of new generation of thinking, machines and whatever, we've seen some of this laid out in some of the science fiction movies, but again, I think that, all sorts of human relationships will be altered. I mean, there's many things that we think of as going on in the world that just simply are just wrong, based on a false premise. So I think you're going to see all sorts of changes that downstream will basically change civilization as we know it.
Can you give me an example? Things that are going on, you suggested, now.
Well, right now, again, I'm giving you the most concrete example is again, the artificial intelligence. I mean, if we want to have a new generation of machines and computers that can think and act like we do, again, we need to understand what is going on and how this works. So I think that as soon as we change our perspective and look at this whole issue of what are these algorithms, what is consciousness, how does that account for what's going on and what we're observing in the physical world, I think then we can put the pie together and at that point be able to create, hopefully not too far downstream, machines, for instance, that can think, the new generation of artificial intelligence. So
I've heard some people suggest that consciousness is simply self-awareness. Is that I think, on or off base?
Well, I think, it's part of it. I mean, I actually published a paper with the famous behaviorist B.F. Skinner called Self-Awareness in the Pigeon. And so, I think that, self-awareness, is part of a consciousness, obviously, because, what is consciousness? It's the me, it's the I feeling, and so obviously you're aware of yourself. Now, in lower animals, for instance, that gets a little fuzzy. We showed in our particular experiment that pigeons had self-awareness, but in the field of psychology, there's several famous experiments where they actually showed that only higher primates have this self-awareness. But there are degrees. So we showed in our paper in Science that actually pigeons and even lower animals have certain aspects of that self-awareness. And so, you can dissect what that means. But consciousness in the way I'm talking about it is in the big picture. I'm talking about consciousness is actually part of the process of reality as we know it, and it starts to explain what is going on in the world in terms of the foundations of physics, in terms of all these various experiments, that we've talked about.
Mm-hmm. What does all this mean about death?
So, right now, again, we think we just die and rot into the ground, and that's really, a silly idea, and it's really based on, our view that, we are associated with bodies, and we know that they self-destruct. So again, there are these experiments that collectively suggest that whole view of the world is wrong. In fact, I mentioned some of the quantum physics experiments, but one of the mainstream interpretations, actually, in the physics community is something known as the many-worlds interpretation. And what that states is that there's an infinite number of universes, quote-unquote, the multiverse, that correlates with this range of possible observations that we see in the micro world. So everything that can possibly happen occurs in some of those in one of those universes. So in that sense, death doesn't really exist. In all these possible universes, they exist simultaneously, regardless of what happens in any one of them. And what biocentrism actually does is it extends that idea and suggests that life is an unfolding, an adventure that really transcends our linear way of thinking. So although our bodies, again, self-destruct, that me feeling is just energy that operates in the brain. And we know that energy doesn't go away at death. One of the surest principles of science is that energy never dies. It can never be created or destroyed. And so when we die, we don't die in this random billiard ball matrix, but in what I call the inescapable life matrix. So life has this non-linear dimensionality that transcends any individual history, universe. It's sort of like a perennial flower, that returns to bloom in the multiverse. So like in that science experiment I had mentioned earlier, whether you're flipping a switch or making other choices, it will be you who experiences those various outcomes in resulting universes. So death doesn't really exist in a timeless, spaceless world.
Would you care to speculate on what that is going to mean for us at death in a way we can understand?
Well, I mean, I think it's very much like going into a different room. I think that we know, for instance, that you can watch a movie and it's real and it's exciting, but that when it's over, that is over, but it doesn't mean that goes away. So it's very much like your vinyl record that you listen to one song and that's the now, that's the present, and you can move the needle, and there will be other places before or after that that will be in the now where it is. But just because you listen to one song doesn't mean the other ones don't exist. So I think all the ranges of what's possible are possible. The problem we have in thinking about death, and this is, again, what Einstein was alluding to when he says that the past and present are just, illusions, is that we think of it in this linear way that, we just die and that's it. And that is exactly what's going on with those entangled particles that, the spooky actions at a distance and all this. Our whole idea of space and time, we got the foundation wrong. They are the way the mind puts it together. They're not real absolute realities that exist out there, and again, that was what Einstein, introduced into our understanding of the world.
Energy remains, but do you think consciousness continues in a coherent manner?
Yeah. So again, what's going on is there energy itself is just really the foundation, the fundamentals of what we experience in the physical world. So matter, as Einstein said, E equals mc squared, is that matter is energy, vice versa. We know you can create particle, antiparticle pairs from just pure energy, and we know that you can, if you introduce an antiparticle with a particle, that they will disintegrate and just into energy itself into electromagnetic waves. So again, we know that everything is made up of energy, and energy is actually motion. It's actually something happening in time, a temporal activity in space, a change in space. So again, those are already in the external world. That is how the mind actually, if you dissect what's going on, would be reduced to. And that is what we're studying in these quantum experiments. We're going down, studying actually electromagnetic energy itself, waves, particles of electromagnetic energy are called photons. And those are the particles, for instance, that we're studying in many of these experiments.
So death, as we perceive it, is, I don't know, just our own perception? There's no real death, if what you're saying is accurate.
Right. I mean, think about it. Death requires there to be time out there, some invisible matrix that, we don't see out there just ticking away, and that's silly. That's just simply not what's going on out there. So again, if time isn't this external thing that's just out there, then that's how come we think of death. We think of that, well, when I die, after me, and that's again why you're running into all these same contradictions. Why are we on top of infinity right now, on top of all of time? I mean, again, lots of very silly ideas. Why the Big Bang? What happened the day before the Big Bang? I mean, these are all silly questions that are based on a wrong understanding of space and time. And Immanuel Kant, like I said, laid this out in his Critique of Pure Reason a long time ago, but it was so heavy. Now, I know people recognize him as a genius, but actually there's a fun little story that when Hubert Spencer, actually, who was one of the great philosophers at the time, when he read his book, threw it on the ground and said, he's a stupid man. And it turns out that even one of his top colleagues, when he got the manuscript when Immanuel Kant sent it to him, got halfway through it and gave it back to him, and he said, this is just too barbarous for me to read, and said, I can't understand this. So the problem is that we think very superficially, and we open our eyes, the world is there, and we can't think much further than that. I mean, again, as I mentioned earlier, we're like a chipmunk or a squirrel. So I think that this is part of the problem, and I think that what we're confronted with now are new experiments that are now saying, well, unless you keep ignoring the experiments, this is the way it is. And so we need to change our worldview, the way we see things. And time, again, being this object or invisible matrix out there is just silly. It's wrong. And at some point, I think, we're going to have to accept these experiments and realize that.
Well, all right. 1 second before the Big Bang. That is an important question because I know you're saying it isn't, but it is because we want to know if there was a hand that created it or whether it was just, I don't know. I don't know, and nobody knows. But it does seem like an important question. You sort of dismissed it, but there was no time until there were objects. When there were objects, we could look at the movement of those objects and measure the movement. Hence, there was time. When you have movement, you can measure. You then have time, right?
So, okay. So let's just think of this in steps. Okay, right now, as we know from the experiment, no particle that you can possibly observe has any properties until you observe it. So that means only now when you're observing something does a particle actually manifest itself. This is the two-hole experiment. When you look at it, you see it, it acts like the board, it goes through that hole. But if you don't look at it, the reason it can go through all these holes at the same time is simple. It's what we, in physics, they call a probability wave. It means it's just potential. And so therefore, it's only when you decide to observe what happened to it that it will actually collapse and have basically done something, because the probability waves are not real things. They're just statistical projections. So again, what's going on here are that we right now look out at the room, you see an object, okay? You're sitting on a chair. Now, you're sitting on a chair, and you know that chair is on the Earth, which is spinning around on its axis, and that's going around the sun, which is going around in the Milky Way, and that's in the universe. And you can project exactly all the spatial logic until you come to the known and edge of the known universe. So that's an exhaustive extrapolation of the logic of you right now talking to me on the phone. Now, you can say, well, you and I are made up of molecules, say, for instance, carbon. Now, carbon, we know from, your basic science books, is formed in the heart of exploding supernova, which are formative events in the universe. And if you extrapolate all that logic back to its ultimate extreme, you come back to a singularity where matter goes down into its smaller components, the plasma and the nuclei and the electrons, and then eventually down to nothing. So if you think of the universe, sort of think of it like one of those globes that you used to have in the schoolroom. You think of the world, and that round sphere is just a concept of, in theory, if you were to be everywhere on this planet, this is what you'd have, is this round ball. But it doesn't mean that you can go to Antarctica or whatever. Likewise, the universe is a concept. It's basically all of the logic associated with your existence. And so again, right now you're sitting on the chair. I can extrapolate all the way out to the edge of the known universe. But as John Wheeler pointed out, even light coming from the edge of the universe, the path will not be determined until it's observed. And so when you observe it, you're actually in this guy was the guy, again, who coined the word black hole, wormhole. I mean, this guy was not a dope. He was actually one of the colleagues working with Einstein. He says that when you observe that, you actually are determining what path that light took billions of years ago. So again, this is hard to wrap your mind around, and even Stephen Hawking now, again, as I mentioned earlier, is changing his perspective and is now having to agree, obviously based on the data, that what happens now in the present actually does impact our history and universe. And so what happened before the Big Bang, you're talking about the end of the extrapolation. The extrapolation goes back to nothing. So those are just the theoretical way our mind would say. If we were to go and project back, all the way back in the logic, this would be the complete logic that explains who you are, if that makes sense. I know.
I'm not sure. I'm not sure.
Yeah, that's a lot of information, and this is exactly why physicists and scientists are struggling so hard with these newer experiments.
And so, would there or would there not be consciousness involved in the Big Bang. I almost said creation, but I'll say the Big Bang.
So again, the whole the whole thing again is when you think about the Big Bang, it's really no different than looking at the moon or looking at your chair. Again, without an observer, not a single particle, whether it was in the Big Bang or in your chair, whether it's part of the moon or your kitchen, has any definite properties. So until they're observed, they exist only in what we call probability waves, or they're only the potential. So again, as in the two-hole experiment, which again goes to the core of this whole issue, is that those particles basically will not go through one hole or the other until you look at them, and until you do that, they could be.
Doctor, hold it right there. I'm sorry, we're at a break. There was no prior to the Big Bang. There was no mass, right? So let me think about that. I'm Art Bell. Heartaches and headaches. That's what you'll get from trying to think about what we're talking about tonight. My guest has been compared to Einstein, Robert Lanza, Dr. Robert Lanza, and he is a pioneer in cell research. I'm going to ask him about that. We'll get to that. But if I think along the lines of what Dr. Lanza is saying, and I consider the Big Bang, prior to the Big Bang, there was, we'll see if he agrees, no mass, so there was no gravity, and there was no time, because time is a construct, according to Dr. Lanza, in our own minds, right? So Big Bang, no mass, no gravity. My question would be, if that is so, and I bet he agrees, perhaps not with this part, then how did the Big Bang happen without conscious direction or without consciousness being involved? Because at that time there was nobody, well, none of us anyway, to observe, right? So there must have been consciousness involved with the Big Bang. Certainly wouldn't be our consciousness, would it? Dr. Robert Lanza, back in a moment. Well, all right, let's try it out. So, Doctor, the Big Bang, prior to that, no mass, hence no gravity. And I guess my question would be, how did the Big Bang happen without consciousness of some sort being involved?
Well, I think, part of the problem here is that we're thinking in terms of the old paradigm, and we know the world just isn't out there independent of the observer. So again, that indeed is consciousness. So that when you think about whether, it's the early part of the universe or even earlier all the way back to the Big Bang, that is basically what you would see if in fact you were there. So in fact, if you were the observer, you could actually trace back you talking to me right now, all the way back theoretically to the moment where the logic is that actually comes to an end. So if you think about right now, you're a human being, you're made up of the carbon molecules. Again, some of those molecules were made, along the way, during the evolution of the Milky Way and other earlier stages. And then just after the Big Bang, actually, as you go back in time, actually the atoms start to then the components that actually made up atoms were formed. So the electrons and the nuclei, they were formed. Then you can go back even further to, there are different particles inside those particles that, in theory, go all the way back. And then just before that, when you come to the bottom of that whole the backwards in evolution, you come to the point of where the logic starts. So it's basically an extrapolation of our own existence, of our spatial temporal thing. So again, it's like that round globe we were talking about. You have the globe, and in theory you could go to Antarctica, but until you don't know whether you can really get there, and so you could never go back to the Big Bang. It's only theoretical. So, but that is in theory what you would see. But so if there is no observer, there is no reality, and nothing. So before the Big Bang, is meaningless. It has no meaning because, in fact, at that point, you've gone to the bottom. Just like
right, but the Big Bang has meaning, and without anybody to observe it,
there would be nothing. Which is
... There would be nothing. So
nothing.
How did it even in fact, occur without a conscious direction.
And you're exactly it. And if there's nothing, then there was nothing there to observe it. And so you're getting into this sort of circular words. Our languages and our science are very primitive tools. So what happens is that in physics they say that everything exists in this probability state, and it's not until you observe it that anything at any point in the universe or any place in the universe could exist. And that applies in whether it's just after the instant of the Big Bang, if you want to talk about it that way, or in the future or the present, or whether it's on the moon or here on Earth, everything, even according to even the experiments in the micro world, they're probability states. And not until the observer is involved, and again, that's because reality is a process that involves our consciousness, they're not there. But anything that is part of that spatial temporal logic indeed would only exist, obviously through the process of consciousness. I know this is...
it's okay. I'm with you until we begin talking about that Big Bang. And how did the Big Bang even occur without conscious observation?
Well, again, this is it. The Big Bang no more occurs than anything else. So again, John Wheeler's line, no phenomena is a real phenomena until it's an observed phenomena. So whether you're talking about the Big Bang or your table or your chair, again, every one of those particles is just an uncertainty wave, and they don't have real particles and real properties until they're observed. So whether you're talking about now or the Big Bang, nothing changes. Is that making any sense?
I'm not sure.
Yeah, it's tough because
I'm not sure. In other words, nothing is until it is observed, and yet we know the Big Bang occurred.
Well, we don't know.
Though we didn't observe it, your theory suggests that it was observed.
No, not at all. No, I'm not saying.
No.
As a matter of fact, what even John Wheeler was saying is that there's light reaching the Earth today from distant parts of the universe that didn't even exist, and when you see them, only then does the path of that light and the existence of that light actually happen. So there are probably many physicists who would also agree, possibly even Stephen Hawking, that the point is there's whole parts of the history of our universe that until they're observed, they don't exist. And it's uncertainty. That's, again, one of the foundations of quantum theory in physics is that there's uncertainty in virtually any possible event, and until you observe it, that uncertainty doesn't go away. So anything in the past, as in that science experiment, what you do right now, again, in that experiment, they actually sent particles into it, and it was what you did now in the present actually could change what happened in the past. So there's uncertainty in, again, this is now Stephen Hawking's new top-down cosmology, that you have to have the present before you can have the history. And so, again, this is the problem with the Big Bang, is that we're used to thinking of the universe in reverse. That it was this Big Bang, and there were all these little molecules bouncing around, and here we are. And, in fact, that's wrong. The problem is that it actually goes in the other direction. It's the observer creates the properties of the particles, and the causality that's associated with that then has collapsed. The probability waves for the whole universe, for our whole history, at that point take on a real form, if that makes any sense.
Well, then it would suggest there is a power or property in consciousness that we don't understand at all just yet.
Well, this is exactly it. I mean, what has happened, unfortunately, is that science has just made it like this big black box, and so they try to come up with these theories of everything and try to explain the Big Bang, and they try to explain the universe, and without any reference to consciousness, which is exactly the problem. And exactly all the experiments, even Einstein with his space and time, he knows that they're relative to the observer. So that's exactly what's going on. This is until we tackle the problem of consciousness, we cannot know what's going on in the physical world. And our theories will not make sense, and they will never make sense until we understand consciousness.
Yeah, I might be willing to go along with that. And we're not very close to it, are we?
No, not until we change our mindset. I mean, I think that, the fact, that you recognize the importance of consciousness, I think this is the kind of thing we need to try to convey to get people to understand that, again, you can't just dismiss consciousness as this little pesky thing, sort of like, a biologist would swat a mosquito in your way. It's a very real problem, not just for biology, but for physicists as well.
There seem to be suggestions that consciousness may be able, for example, mass-directed consciousness may be able to affect complex things like the weather. It certainly can't dissolve the desk in front of me, nor the phone, nor the electronics I have in front of me right now. Can't do any of that. But these complex systems, like the weather and other things, seem to be able to be affected by consciousness. Now, I realize that's out on a limb, but that's where I live, out on a limb. Have you thought about that at all?
Well, again, I'm schooled in, all the dogma of science, so, I only can go very cautiously into certain areas, and so I've only ventured the first step of the way. But certainly, again, we know that every aspect of the weather is obviously has something to do with your consciousness. Obviously, whether it's color, the brightness, or whatever, all of those things are cannot be divorced from your consciousness. Now, whether or not we can manipulate them, again, we do know at the micro level that your choices and what you think and what you can do can impact to a certain degree what happens to the properties of those particles. Now, whether or not you can manipulate in any way the weather and how that might work out in terms of causality, that's beyond me. But maybe someday we'll figure out if there's something to it. Like I said, I mean, there's so much we don't understand, and we only probably understand less than 1% of what's really going on. So who am I to actually say what could really be going on or potentially be possible?
Well, Doctor, considering your background, even what you call the small step you've taken is a gigantic step, and I imagine it's caused all kinds of controversy. In other words, I would think that a lot of the people in the hard sciences are pounding on you for what you're saying in this book.
Absolutely. The problem, too, that makes it doubly difficult is that every time they criticize the idea, they're criticizing it from within the old paradigm, which, of course, makes no sense. And so they'll actually say something to me that actually has nothing to do whatsoever with the way it's being presented in this new system. So I think this is nothing new. Anytime you have a new world view, I think it was actually Arthur Schopenhauer once was famous for having said that, I'm trying to think of the exact quote. It was something about all truths go through three phases. First, they're ridiculed, then they're violently opposed, and then they're accepted as self-evident. And I think anytime you introduce any new idea, they're going to go through that phase. And I think I've gotten the ridicule and now violently opposed. And the next thing you know is that once people start to realize that, you can put the clock together better this way, that then they'll say, oh, well, that's self-evident. We've known about this. People have been saying this for thousands of years. And this is the problem. You can get accused of pseudoscience if you're too far apart from the existing science. And on the other hand, if you're not sufficiently different, then they'll just say it's old news. So you're sort of caught between a rock and a hard place.
Well, you jumped in between the rock and the hard place by writing this book. Did you think long and hard before you wrote this?
Yeah, it's very, very difficult because, again, I'm not totally stupid, and I realize, I grew up in this society. And I know, you walk down the street and the street's there and the moon is there, and believe me, I mean, that's how, I grew up with that same worldview. And then when I started to see the contradictions and that it just didn't add up, and then started to consider the experiments, you start to move, and you're going, well, we haven't moved far enough. And then I knew that you're going to run up against, remember, ever since we were little kids, we get bombarded through our books, our schools, and all, with all these ideas, and you can't just throw them away. So, yeah, when I wrote this, I knew I would get hammered. I knew I would get slammed. And so I tried as best I could to explain it in terms that I thought people could understand. And it's hard, unfortunately, to explain it in a few minutes or even an hour. And so that's why I wrote the book. But if you don't read the book, then what happens is you trip up very easily. In other words, you showing someone the nucleus of a new world view, and it's like walking around in the dark. You can trip and stumble, and you go, well, this is silly because of this or that, and you can come up with all sorts of reasons and ways to refute this because, you're unfamiliar with it, and every time you try to think of something, you revert back to the way you were trained to think. So
all right, look, Doctor, we're at near the end of our 2 hours. That's how quickly it goes. Now, if you're unable to stay any longer, there are a couple of questions I've got to ask you. Can you stay longer or not?
I can add on another 10, 15 minutes if you'd like. Yeah.
10 or 15 minutes. That's not much. All right.
Okay.
You were part of the team that cloned the world's first early-stage human embryos for the purpose of generating embryonic stem cells. So we all know about all the controversy involved in that. What I would like to ask you is where we are now with adult stem cells replacing fetal cells for the purpose of cloning. Are adult stem cells going to end up to be as useful as fetal?
Well, what is happening is obviously there are embryonic and fetal tissue, and there's also the adult, and there are pluses and minuses for each of those. I mean, we've been actually using adult stem cells for bone marrow transplants, for instance, for cancer, for literally decades. So we know that they work very nicely. The problem with those is that you can't make all the types of cells and tissues you would like to try to cure various diseases. So they have limitations. But what has happened is that there's been a very remarkable breakthrough very recently that hopefully is going to solve all of these problems. It turns out that we can actually make stem cells, just like those fetal or embryonic ones, from adult tissue. We can take a skin cell, and actually we've now learned how to do sort of what an egg or what an embryo does in terms of actually having this plasticity to become every type of a cell. So if I take a skin cell, I can actually upregulate certain genes and make it now a stem cell, just like an embryonic stem cell, and it can make all the tissues of the body. So that's where we're at now, and this is what we called iPS cells, induced pluripotent stem cells. And so we're on the verge now of hopefully getting that technology to work in a way that we can now use it in the clinic to help people. In fact, I just published a paper a few months back showing that we can now actually make those kinds of human stem cells using proteins in a way that's safe, because the way it was originally discovered a couple of years ago was using viruses, which, of course, the FDA would never allow you to use in people. So we're moving very quickly, and I think you're going to start seeing some treatments appearing very, very soon. In fact, we've applied with the FDA to start to try to treat blindness using retinal cells that we made from these embryonic stem cells, and hopefully we'll start clinical trials this year on that. But we're also in the process of now using the iPS cells that were actually created from adult skin cells. And so I think you're going to see a lot of exciting things happening very soon.
So the answer is yes and no. In other words, yes, eventually adult stem cells will be what you use, but at the moment there are still properties in fetal cells that simply have not yet been...
Well,
I'm not sure how to phrase this, haven't been what? The adult stem cells are not yet quite as useful as the embryonic ones?
Yeah, so again, in the scientific community, in the stem cell field, what we call an adult stem cell is a cell that you get from the body, and it's normally in all your tissues. So, for instance, your skin, you have stem cells, and in your brain, you have stem cells that can make the various brain cells. And those cells are very limited in that, say, for instance, a brain or a nerve stem cell can only make other kinds of nerve cells. So we're now learning how to turn those cells in so they can do everything. So, and that's happening.
Doctor, hold tight. We're at a break point, and then I'm going to steal 10 more minutes from you, and then we'll go to open line. So, Doctor, hold tight. Dr. Robert Lanza is my guest. Biocentrism is his book. I suggest if you want to know more and really understand biocentrism, you go buy the book.